Okay, friends, I see that this is kind of offset. I guess when I adjusted it and saved it, it kind of got messy, but that's okay. Give me room to work. This is one of the 2 sheets that I gave you to practice Unit 4 on Friday. Excuse me. And so we just need to review the rules for solving equations with variables all over the place. So here we have variables on both sides. And unlike systems, we only have one variable to solve for. We only have to focus on one variable. And here it's consistently x, which is nice. So what would be the first thing I would do? Well, if you recall, we always encourage you to draw the line under the equal sign so that you can see when you're combining like terms versus when you're moving it on the other side of the balance. So what's the goal? The goal is to get all the x's, all the variable terms on one side of the balance and all the non-variable terms on the other side of the balance. In order to do that, I need to spend 16x over here. And that will leave me with no x's, no variable term. But in order to maintain the balance, because by spending 16x on the right side, you've just made it lighter. You've removed 16 x's from the right side. So it's no longer balanced until you also remove 16 x's on the left side. Well, you only had 4 x's to spend. So that means you're going to be in debt 12 x's. And that leaves you with a remainder of 2. Now this is kind of awkward looking because now at this point we're going to divide by negative 12 to get x by itself. Positive 2 divided by negative 12 is going to be negative 2/12, or you could reduce back to 1/6. And even though we're not used to ugly answers like this, meaning rational fractions, decimals, those kinds of things, it's not really about the solution. Right now it's about identifying whether it has one solution, no solution, or infinitely many solutions. So here, what is this? This is going to be one solution. You have an x you had to solve for. And at what step could we see that that was true? Well, pretty much from the very beginning. Because unless the variables zero themselves all out, when we were dealing with systems, we had to have both variables zero out. But here, we only have to have one variable zero itself out. So it might look like negative 3x plus 2 equals negative 3x plus 4. And then therefore the variables would zero themselves out when you would go to oops, that should be an x. So here the variable didn't zero itself out. It didn't cancel itself, so therefore there is one solution. So moving on, let's try the next one, number 2. Here we have some fractions we're dealing with, but remember, fractions are friends. They both have the same denominator, and they're both part of the variable term, so that leaves it easy to work with. So I'm going to, leaning on it, and it's not too heavy. I'm going to subtract 1/2 x from this side, and 1/2 the x from this side. And so we see we're going to be left with 2/2 x, or also known as 1x. And we still have plus 2. And we have equals 4. So now what do I do? Well, do I need to finish solving this? If I do need to solve it, I'm going to subtract 2 from both sides. And 1x is equal to 2. However, we didn't really need to solve it because what we're being asked is it one solution, no solution, or infinite solutions? And we can see that there was a solution. The solution was 2. So there was definitely one solution. How else do we know that it was one solution? The variable didn't cancel itself out. The variable didn't zero itself. All right, how about number 3? Again, what we're seeing is there the same variable on this side that is on this side? The same amount. If that's true, then of course when I go to subtract 5x and subtract 5x, what's going to happen? All x's will zero themselves out, and I will be left with 8 equals 11 plus 6. Okay, so now we know there isn't a one solution. There has to be either a no solution or an infinite solution. Well, which is it? Well, if I finish the math, this says 8 is equal to 17. Well, we know that's true, not true. 8 does not equal 17, and so therefore there is no solution. Okay, let's take a look at the next one. Again, we see that there is a 6x on both sides. So therefore, if I were to subtract 6x and subtract 6x to keep the balance, again, my variables are going to zero out. So what does that leave me with? Well, it leaves me with negative 8 is equal to, what is negative 10 plus 2? If I borrowed $10 from a friend, but I pay them 2 back, I still owe them 8. And when negative 8 is equal to negative 8, which is a true statement, we have infinitely many solutions. All right, let's take a look at this one. Now we only have one fraction, but it is in the variable term. And what do we notice about this fraction? It is an improper fraction. The top is heavier than the bottom. So we can divide. We can say 9 divided by 3 is 3x. And again, there's the line at the equal sign. So 3x, what is a negative 11 plus 2? It's negative 9. So on the left side, we have 3x plus 9. On the right side, we have 3x minus 9. So before you go jumping to conclusions, let's just check it out. We're going to take away 3x on the one side and spend it to get it to 0. And then we do it to both sides, and we find that they both zero out. So it's not one solution. What are we left with? 9 equals negative 9. Is that a true statement? No, it's not. They are 18 units apart. So, no solution. They try to trick you sometimes. Oh, I see 2 9s on each side, and one on each side of the equal sign. But if you look closer, one's positive, one's negative. That is not the same. Last but not least, this is going to require a little bit more attention to detail. So we're going to draw our line under the equal sign, and the first thing we have to do is combine like terms. So let's focus on the left side for now. We have 1/2 x and a plus 4x. Can I add those together? Nope, can't add those together because they don't have the same denominator. What's the denominator of a whole number? It's over 1. So how can I get the denominator of the 4 over 1 to be over 2? What do I need to multiply the 1 by to get it to be 2? Well, I multiply 1 times 2 to get to 2. So then I have to multiply 4 times 2, and I get 8. 8 halves is the same as 4 over 1, x minus 5. Now I can add those two terms together, and I get 9 halves x minus 5. Let's take a look at the right side. We have to do the same thing. Again, this is 8 over 1x, and we want them to be both over 2. So what did I have to multiply the denominator by to get it to be 2? 2. 1 times 2 is 2. So then I have to multiply the numerator times 2. And I get 16 halves. 16 halves minus 7 halves is also 9 halves. And 9, positive 9 minus 14, again, it's a calculator unit, gives you minus 5. Oops, I forgot my little x there. 9 halves x minus 5 equals 9 halves x minus 5. That's a true statement. They are already both balanced. If I were to subtract 9 halves x from the left side, and of course to keep the balance from the right side, both of my variables would zero out. And I'd be left with negative 5 equals negative 5. This is an infinitely many solutions. All right, I hope that was a good review of these concepts, and more on this on Monday.